water efficiency doesn't always get included, and so we're very grateful for this opportunity. Water management often gets included, but not efficiency as a separate topic. And this is something that we want to elevate as a discussion nationally for a whole lot of reasons that we'll talk about today in this discussion. So I've been listening to everything this morning with great interest. I'm very happy that I'm an example of your walkable urban design paradigm, because I live 2 blocks from the office in downtown Chicago. Our office is across the street from Sears Tower. My apartment is 2 blocks away in the old repurposed Florsheim shoe factory. And I love it. I love my commute. It's 4 minutes walking. And I can't imagine anything more sustainable, so I'm very, very happy to be an example of that. And yes, I agree with a lot of the speakers today who have said LEED really was transformative. LEED really began us on this path. And LEED started, of course, on water as well. But in the beginning, LEED considered water almost as a nuisance issue. How do we collect a lot of the water and infiltrate it on site so that it doesn't run off? They really didn't consider it in the same way from the efficiency standpoint. And I give as an example, in the very first set of LEED specifications, you got points for just complying with federal law. If you put in one of those 1.6 gallon per flush toilets, you actually got points for it, even though that is all you could legally do under federal law. So, of course, many changes have happened since then, and that no longer is the case. Now, LEED, as of 2009, has a baseline requirement that you have to be 20% more efficient than those legal flow standards in order to qualify for points under LEED. So we've made great progress, but it's because we've been working very hard with USGBC. We've been very involved in the Water Efficiency Technical Advisory Group. So, you know, LEED has now made great strides forward, and we're very happy with the current state of things and how it's evolving. But for us in water efficiency, it always feels like we make 1 step forward, and then we make 2 steps back, and then we have to make another step forward, and then we make another 2 steps back. And I given as an example of this the federal flow standards I just mentioned. We've had a shower head standard in effect since 1992. You couldn't buy a shower head from 1994 on that didn't flow, supposedly legally, at 2.5 gallons a minute or more. They all had to be 2.5 gallons per minute or less. That's been in effect for a long time. But you see a lot of shower heads out there that don't comply with federal law. It's just the way it is. I mean, some manufacturers actually bundle in their instructions for the shower head, instructions to the consumer on how to drill out the restrictor or otherwise alter the shower head so that it flows at a higher, more acceptable flow rate. 2 weeks ago, I was in Carmel in the Monterey Peninsula, arguably an area of water shortage. And my particular bathroom had a shower head, very illegal shower head, that floated about 13 gallons a minute. It was one of those rain showers that you see advertised on the internet. And I was just like, I mean, it was like a waterfall. And if you took a shower this morning and did a hotel this morning, how many of you noticed it's not exactly 2.5 gallons per minute here either? So this is the kind of 2 steps back that we always take, because the perception on the part of the consumer and the user is always, we have plenty of water. Why am I stuck with this amount of flow? And so it has a permeating effect in how we progress forward, how we develop standards, how we work together as a community, and it affects how we now are perceiving the consumer is participating in this discussion. They still don't have a good understanding of where their water comes from, how their role in water management is important, and all they really think about is the bill. The customer is very concerned about water rates going up. It's outrageous that there's a 40% rate increase. Even if the absolute value is $10 a month, it's still outrageous. And they call their utility offices to complain about the high bill from their cell phone, which costs sometimes 5 times more. So we have a distorted sense of worth of water in this country. We have the most safe, affordable drinking water in the world. It's about 1/10 of a gallon in some places, 1/10 of a cent per gallon in some places. But instead, our consumers, having no faith in that water, will go and buy bottled water at almost 10,000 times that price. We have a problem in this country, and so I'm going to return to that at the end because I think it's going to be fundamental to some of the changes that we want to talk about. So how do we get some of those changes to go forward? Moving towards a water efficient future, the way to do it is by using the vehicle of shortage. When do people pay attention to how they use water? It's when suddenly they're in a drought or some sort of shortage situation. Might even be a permanent shortage situation depending upon the water supplies in their local community. And that shortage is largely already here. We've had a massive drought in this country that's affected the agricultural farmer. Not so much the urban areas yet, because we've had 2 wet years where reservoirs have largely filled up for urban water systems. So the drought yet isn't real pervasive in the urban communities. It hasn't been felt yet in the urban communities, but it's really being felt in the agricultural sector. 65% of the counties in the US are in drought. But when you think about the urban systems are where people get their water. And the drought has the effect of emptying and stressing reservoir systems. This is a picture of Lake Oroville in California during a particularly dry year. The next year it filled. Now it's going back down again, but it's not going back down again at a rate that is panicking anyone in California. But by next year, it probably will. When the reservoir was this low 3 years ago, there was lots of talk about making changes. In fact, California even passed a law requiring that all water systems reduce their use by 20% by the year 2020. It's the only state to have done that. So shortage drives perception and need for change. But if you ask the 50 states, and the last time the federal government asked those 50 states, when do you think you'll be in shortage? The answer was by 2013, because this study's fairly old, but goes back to 2003. By 2013, 36 states responded that they felt there would be some sort of shortage, freshwater shortage in their communities, either regionally, locally, or at the state level. But as I looked at this map, I thought, well, California, Nevada, and New Mexico are indicated as black because they did not respond or they were uncertain as to shortage. And since I don't think it's uncertain, I think they just didn't have time to respond because they were in the middle of the drought, I added them to the list. So that makes 39 states. And then Alabama, which is curiously incorrectly listed on this federal map. Alabama in the Birmingham area declared a local shortage, so that makes 40. So 40 of the 50 states, by what is perceived now to be next year, will have shortages that will affect their drinking water supply availability. And when that happens, then the messages go out about more wise water use. The other driver that I think is going to ultimately help address our need for change in water efficiency is the fact that water and energy are connected. And that connection means carbon savings as well. We think about saving energy. If you save water, we also are saving energy, and we need to better document that connection. In terms of US daily water withdrawals, power plant cooling still is the largest withdrawer of water. Now that's not consumptive use. The water is largely returned up to about 94, 95% is returned back, but it's returned elsewhere. It's returned sometimes thermally loaded. It's a different form of return back to the system. And the water still has to be there to begin with. We're still seeing power plant applications, siting applications being rejected because there isn't sufficient withdrawal capacity from a surface water body to do this cooling. So 49% of the nation's water withdrawals are for energy, thermoelectric power plant cooling. And on the other side, the nation's water supplies and wastewater treatment are largely driven by electricity. There's a terrific energy intensity in that water supply, and it can range from a low of 2,000 kilowatt hours to a high of 20,000 or more. I have a house in a mountain community in California called Lake Arrowhead, and our embedded energy value is 24,000 kilowatt hours when we take water from the State Water Project. So although these look like high numbers, they are not numbers that are out of scale. And California is not the only state to have these kinds of numbers. We're seeing as states begin to inventory the energy intensities of their water supplies that on a system-by-system basis, some of these values can be quite high. So if you're using as much as, say, 3,000 kilowatt hours per million gallons of water, and you're pumping 50 million gallons of water a day in your system, that's a fair amount of energy. So every gallon that you don't pump, treat, and move to the customer, then collect and retreat for wastewater purposes, is energy that you're recovering from the system. And so what does that look like? That basically looks like this. A lot of the energy that's used, of course, is in residential hot water heating. And that is still the largest part of where that energy savings would come from. And energy efficiency programs have recognized that over the years and have incentivized what I call hot water efficiency programs. But they don't incentivize the cold water part of it because it hasn't ever been documented to people's satisfaction that there was enough energy residual in that water that should get federal incentives just for that transport and treatment, that cold water piece of it. But if you looked at it as a whole pie chart, these are the basic breakouts of where the energy use goes. 10% is, 16% is wastewater treatment, and water supply in commercial and industrial areas about 3%. Commercial hot water heating is another 12%, so that's a hot water one. But residential water supply, 5% of the pie. That includes treatment as well. And overall, it ends up being a rough estimate, according to River Network, who put this together, that it's about 5% of the US carbon load. Now, we've heard some really big numbers for buildings' contributions to the US carbon load, but no one has ever really thought that water contributed much of anything. And 5% is not nothing. This is something that we can productively use to advance water efficiency programs going forward because it has a bigger system impact. So looking to the future, what are some of the things that we as an organization, the Alliance for Water Efficiency, would like to see? One of the things we would love to see, and the reason we were very happy to be part of this project, is we'd love to see a truly water efficient home. We are still building the houses the same way we always did. And right now, water efficiency is just considered a simple end-use change in one place or another. Maybe it's a shower head, or maybe it's a clothes washer. But there isn't a change in the intrinsic design of the house that would make the house more water efficient. In fact, we're building houses with master bedrooms and other bedrooms with wings, where the bathrooms are in far-flung reaches of the structure, and the piping to get hot water to those bathrooms wastes a fair amount of cold water while hot water is being sought by the consumer. So most of those houses are still being plumbed in the same general ways. So looking toward the water efficient home, what are some of the things we'd like to see? Well, the first thing we wanted to highlight was the fact that the builder, as well as the consumer, usually doesn't really care much about water. They think of water as a given. It comes from their tap. It's the water supply that's provided by my community. My tax dollars and ratepayer dollars go toward it, so I'm going to have it, and I'm going to use it wherever I want. And as a matter of fact, I started my career as a planner, so when I got into the water business, I kept wanting to go back into my planning roots and combine the water issue with all of the American Planning Association meetings that I was still going to. And I would hold these workshops, how do you plan for water efficient development and deal with water supply shortages in your community. And the planners all had the same message. They would say in these sessions, they would say, it's not our job to worry about water. That's the water utility's responsibility. We just assume the water is going to be there, and we plan developments based on that. So there hasn't been a lot of progressive attention in this area, and the consumer certainly doesn't think that that's something that they need to pay attention to. So one of the first things we did when we created our organization was we developed some website resources to help people through this issue. We have a main website, which I'll show you later, but this is a slide from a site we built for the consumer. It's called Home Waterworks, and it's a calculator that we built together with the Field Museum in Chicago that helps the consumer understand where water is used in their house and how they can change the water footprint of their house. That's fundamental to the home of the future, is understanding where the water is being used today. And the new home of today is, because of the federal standards I mentioned in the beginning, the home of today is more efficient in terms of flow than the home of the past. we've gotten our consumption down around, what the data are currently showing is it's around 35 gallons per person per day indoors. And originally it had been more like 60, so we're making some progress. We have a lot of efficient fixtures that are mandated not only in the Federal Energy Policy Act, but in a whole series of codes and standards that have been adopted to build off of that since then. We still have toilets, again, at 1.6 gallons per flush. We have shower heads at 2.5 gallons a minute. That's the federal law. Top loading clothes washers have a standard of 9.5 gallons per cubic foot. There's a water factor standard. And front loading washers are limited now to 6 gallons per cycle per cubic foot. Dishwashers have been also very productively enhanced in terms of efficiency, and they're down to 6.5 gallons per cycle currently, dropping to 5 by May of 2013. So these standards, which have been very progressive and probably the biggest contribution we've made in this country towards efficiency and development, these standards have been progressively ratcheting down. But they're end-use standards. The consumer has no idea what they are. They just go to Home Depot or Lowe's and buy their product and bring it home. They don't think usually about what that particular standard might be delivering, unless, of course, they don't like their shower head. The outdoor water use is the big problem area. It's highly variable depending upon the region of the country you're in and depending upon the consumer's interest in what they want to do with their landscape. Lawn is still king. We still irrigate 3 times more acres of lawn than any other crop in the United States. So it's a crop we don't eat, but we irrigate it anyway. So the statistics are, that's okay, I don't need it anymore, it's fine, thanks. The statistics are pretty alarming about the Americans' love affair with the lawn, but that lawn needs to be irrigated, and that's a substantial part of outdoor water use. Sometimes in certain regions, arid regions of the country, it can be as much as 80% of residential treated drinking water is going out on the landscape. We don't have any national outdoor standards to speak of. There are a lot of local restrictions depending upon where you live. There can be time of day watering restrictions. There can be, landscaping restrictions of other types. But generally speaking, it's just handled at the local level, sometimes with temporary drought ordinances, not often with permanent landscape standards. So my community in Lake Arrowhead, because it was so desperate about how much it was paying for State Water Project water, we have banned new lawns for new development. And that was something passed by the water district. It's probably one of the reasons why I'm no longer an elected board member on that water district. There were some things we did that I thought were pretty progressive, but not popular, and that was one of those. But standard is still there. You still cannot put in a new lawn in that mountain community of Lake Arrowhead. The gray water systems issue is interesting. We do see gray water applications. They're almost always what I would call quasi-legal, or they're considered pilots by their local public health officers, or like in Berkeley, outright illegal. They've got a group called Gray Water Guerrillas in Berkeley, California, and their mission is to get gray water everywhere, whether the local health officer permits it or not. So gray water is not, ubiquitous and certainly not on a track in the United States the way it is in Australia. And the WaterSense New Homes specification, WaterSense being the Energy Star label for water, WaterSense has a specification for new homes. It is somewhat aligned with the Energy Star new home spec, but it is different, and it's, of course, voluntary. And it has been adopted by some communities across the country, although not in a widespread way. So that's the home of today. The new home of tomorrow is going to be different. It's going to have much lower water use, 20 gallons per person indoors. It's going to have super efficient water fixtures at a WaterSense standard or higher. So here are some of the flow amounts that we think are going to be, the flow amounts of the future for 2020. In 2020, we'd like to see much more widespread gray water systems. We'd like to see microsensors in the landscape area. But we'd also like to see moisture sensors indoors, for humidity control and recapture of that water. Smart irrigation management has to be a must. We have leaking irrigation systems and controllers that are set to irrigate even when it rains. We need smarter irrigation management if we're going to keep these landscapes in place. And we also need to do structured plumbing. We need to design houses where the hot water heating source is closer to the end use, or come up with systems that will, in Gary Klein's famous words, waste no more than 1 cup while waiting for the hot water to arrive. And right now we know we waste a lot more than 1 cup in most of our households. And then smart meters and dashboards where the consumer can actually see what the water usage is in their house. And so this is my vision for 2020, a dashboard in every home where water and energy consumption are connected, where the consumer can track their consumption of these two resources and compare them not only on a trend comparison with what their usage is in the past, but also with what their neighbors are using and what the more efficient home in their neighborhood is using. In our water calculator for the Home Water Works website, we do exactly that. We give them, here's your use if you do these improvements, here's what your average neighborhood usage, and here's what the super efficient home in your zip code uses. So those comparisons we hope will stimulate people to be more progressive. So how do we get there? Just to finish up, because I see I've got my red light flashing. Just to finish up, we came up with a list of things for, how do we get there? And we want to continually progress on plumbing and appliance standards, and we're on track to do that. There's a lot of great work that's happening in this area, so I don't really worry about this one. Requires structured plumbing and building codes. Gary Klein and others are on a mission to make that happen in the codes. There's great progress happening there as well. Require climate-appropriate landscaping of all building lots. Not just leaving the lot and the backyard empty so that the consumer can put in whatever they wish, but actually trying to set some standards for what that backyard could look like. WaterSense New Homes specified that no more than 40% of the footprint could be turf, and they were nearly run out on a rail. That specification element is now gone from the spec. Why do we have this kind of aversion? It's mystery to me. Number 4, require low-pressure micromanaged drip irrigation. This isn't rocket science. We just need to require it. It needs to be not just an option for the progressive homeowner, but something that is a commonplace occurrence. We need to think about gray water, and one of the ways we can get through this gray water barrier is to develop some national gray water treatment standards that has the acceptance of EPA and the Center for Disease Control that really will alleviate the angst that's at the local public health officer level about permitting gray water systems. And then we need to develop gray water systems that have a low maintenance cost, a low installation and maintenance cost so that they're affordable. We don't want gray water systems to be affordable only for the McMansions. We'd like them to be affordable for rank and file housing as well. Smart meters are a must. Utilities who are not installing smart meters as they replace the consumer meter of 30 years ago, if they're not installing smart meters, they're derelict. This is the time to do this. And in water, we need to consider two-way meters just like they have in electricity. Right now, the meter input is one way. It's basically coming out with information, but it's not going the other way with management options. And I think just like with the energy meters and air conditioning shut-off rates, we should offer premium rates to consumers who allow their irrigation systems to be shut off at key drought moments. And those are the kinds of strategies that we don't yet have in water. Number 8, require the dashboards. The consumer, it's been shown that the consumer, when they get the information, they're shocked at how much water they use. Marketing surveys all show people think they use about 10 gallons a day for their whole house. They have no idea what they're really using. And if you give them the information, they're usually taken aback. Really, I use that much? That can't be. So these are an important ingredient to educating the consumer. Enact financing incentives to help builders install the right things and to help home buyers choose the right blue options as well as green options. Let's make the blue options part of the green choices that a consumer makes when building and buying a home. And then lastly, inform and educate the consumer about the resource implications of water waste. And we haven't really done a great job of that in this country. And I give you Exhibit A, which is a book called The Big Thirst by Charles Fishman. And you might remember Charles Fishman because he wrote the book on Walmart. He wrote The Walmart Effect, which was a runaway bestseller and exposed all the stuff about Walmart that we love to read about. So he decided water was the next big issue he wanted to tackle. And he's very, very interested in it now. If you sign up for his Twitter feed, you get several tweets a day about his issues on water. And he's shocked that this book is not selling. He says, the apathy of the American consumer towards water is probably the reason I needed to write the book, but I'm not getting rich writing the book because nobody's buying it because they're apathetic about water. So I have to take this opportunity to promote this, because I think once the American consumer is better informed about what a big part water plays in their life, we hope it will make them more stewardship oriented. So that's the reason we created the Alliance for Water Efficiency, which is really a brand new organization. We've only been in existence since 2007. Here's our Home Water Works website, which we encourage you to go visit. Here's our regular website, it's just allianceforwaterefficiency.org. And so we're hoping that you will visit us and take a look at all the water efficiency information that we've assembled in one place, and help us promote the fact that, you know, it's not enough to be energy efficient, you have to be water efficient too, and the two have to work together. So I appreciate the opportunity. Thank you.